In this video, you are going to learn how to use the valence shell electron pair repulsion theory to determine the electron group geometry. Let's begin with having us to draw a molecule of methane, CH4. We have done it before, and it is C with 4 H connect to it. I would also like to draw the molecule for water, H2O. The Lewis structure for H2O is O over here, H over here, and H over here with lone pair electrons. Now, the question is, what is the angle between these bonds? What is this angle here? And also, what is the angle over here? Okay, so you may think, okay, so over here, one whole circle, it is 360, and therefore this will be 90 degrees, okay? And over here, I see this is a line. That means this must be 180 degrees. Guess what? That is not the case. Why? Because when the carbon forms with 4 hydrogen atoms in 3-dimensional, how would it look like? It will look like this. And it is very obvious that this angle is not 90 degrees. The angle here, it is not 90 degrees. On paper, when we draw CH4, it may look like this. And up there is an H. Okay, it looks like 90 degrees, but in reality, this angle over here, it is 109.5 degrees. Okay, so 3-dimensional, we know that it will be different from 2-dimensional. Let's go back to the water molecule and see what happened here. Is this 180? Well, let's look at this way. We have, this is called a lone pair electron, and we have 2 of those. Each pair, we can treat it as an electron pair. So this is electron pair, 1 electron pair. Lone pair is electron pair. Let me write it down. So what is electron pair? Sometimes we call that electron group. Okay, so a single bond is a pair. A double bond is a pair. A triple bond is a pair. Here's just 1 pair, 1 electron pair, 2 electron pair. To reduce the confusion, let's use electron group instead of pair, because pair somebody may think is 2. Okay, electron group. Let's use this word, electron group. A single bond is 1 electron group. A double bond is 1 electron group. A triple bond is also 1 electron group. A lone pair electron, 1 pair of lone pair electron, it is considered as 1 electron group. Okay, so let's see how many electron groups are surrounding this oxygen over here. Okay, so let's count. I have a single bond over here, so 1 electron group, 2 electron groups, 1 lone pair, so 3 electron groups. Over here, 4 electron groups in this oxygen. That means it will have the similar geometry here. Over here, let's count, see how many electron groups. 1 group, 2 group, 3 group, and 4 groups. Okay, so they both have 4 groups. In other words, their electron group geometry, what does that mean? That means what are the electron groups pointing. Okay, so let's look at this. Imagine this molecule with the red color over here, that is hydrogen. So these two are hydrogen, and this is oxygen in the center here. Here's oxygen. So what happened is, this will be the lone pair electron. Lone pair electron. This will be the lone pair electron. So what you can see is the angle over here is not 180 degrees. It's not like what you saw before. See, on the paper or on the board, you think it's 180 degrees, but in reality, it's not. Each of the lone pair will be treated as one electron group. And because these electron groups, they are lone pair electron, it has more powerful to push this away. That's why this angle, if they share the force equally, it will be 109.5. But since the lone pair electron has too many strong electron force, it pushes it a little bit, and therefore this angle is slightly less than 109.5. Okay, so let's look at another one. What happened with this one? How about the formaldehyde that we have seen before? Carbon over here, oxygen over here, and hydrogen over here, hydrogen over here. Okay, so now, well, the lone pair. Okay, so as for the electron group geometry, or sometimes we call that electron pair geometry. What is it here? Let's look at the carbon and see how many electron groups the carbon has. Okay, a single bond is treated as one group, single bond one group, double bond also one group, just like how many branches coming out from the carbon. Okay, so now carbon has 3 electron groups, and therefore this angle over here will be very close to 120. So each of them very close to 120. In reality, there will be more electron over here and push it. That's why this one get a little bit bigger than 120, a little bit bigger than 120, and this one will be a little bit less than 120. Okay, because the electron, there are so many electrons on this side. But if everything is ideal, let's say if 3 of them are oxygen, such thing that we have seen before in the resonance form of the carbonic anion. Okay, so in that case, you will have something like this. And therefore, this angle will be exactly 120. Okay, so let's look at this oxygen over here. How many electron groups? 1 over here. Each lone pair electrons will consider as one group. 1 lone pair, 1 group. Okay, they always come in pairs. 1 group and 1 group, also 3 groups. Okay, so if we want to draw the angle between here, it will be 120, about 120. Okay, so this is the angle of the electron group. It's not the angle of between the atoms. Okay, this one is between the atoms, but it's between each group. Over here is between each group, each electron group. Okay, we have special names for those groups. For example, when it's linear, if it's really linear, no lone pair electron here, then it will be 180. Why? Because these lone pairs, this electron group that is made from valence shell electron pairs, or because this thing is from valence electrons, that's how we drew the Lewis structure, by using valence electrons. That is why this is called the valence shell electron pair repulsion theory. Okay, so if we only have two electron groups, yes, they try to push each other because negative will repel to negative. That's why we get as far as possible, and it will be 180 degrees. If I have three electron group pairs or electron groups over here, then it will be 120 because they try to push each other as far as possible. And there is a special name for it. If I only have a line like this, it is called linear, and the angle is 120. If I have three branches or three electron groups coming out from the center here, it is called trigonal planar. And the angle between each electron group, it is 120. Over here, if I have four groups, such as the methane molecule, because of four groups, and I have mentioned before, the angle between each group over here, each electron group, it is 109.5. And the special name to call this is tetrahedral. That is about the electron group. Okay, so if I have 5, so 5 will go like this. Some of them will form a triangle over here, and one go on top and one in the bottom. So between, on this plane, this is 120 and this is 90. If you have 6, that just like the XYZ axis, each of them will be 90 degrees. This one, because if you look at this thing forming something like this, that's why it is called trigonal bipyramidal. Okay, you see those triangular pyramid, okay, and that's why it's called trigonal bipyramidal. Okay, and this one is called octahedral. The angle between this, the closest electron group, it is 90 degrees. Okay, let's try some exercise. If I ask you to find out the electron group geometry of the carbon in carbon monoxide, CO, okay, so what should that be? I would like to know the electron group geometry of carbon in carbon monoxide. Okay, first we have to draw the Lewis structure of carbon monoxide. In order to do that, we need to find out the total number of valence electrons. So for carbon, it is 4. So I'm looking for total number of valence electrons. Carbon is 4, oxygen is 6. So totally I have 10 valence electrons. So I place them here. I first connect it with a single bond. So I used 2 electrons. So I have 8 electrons left. So I'm going to put them all in. I'm going to write it like this. So totally I would have 5 of the electron pair. 1, 2, 3, 4, 5. Okay. The next thing is I would like to check, see if they satisfies the octet rule. So the next step is octet rule. Okay. So I'm checking with the carbon. I have 1, 2, 3, 4, 5, 6, 7, 8. So carbon is good. Oxygen, I have 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is good. Now, how many electron groups does carbon have? 1, 2. It has 2. Why? Because a lone pair electron, like one pair, we treat it as one group. Over here is another group. And therefore, this one is linear. The angle here between the 2 electron groups will be 180 degrees. Let's look at the oxygen. 1 electron group, 2 electron groups, and therefore it will be linear, and it is 180 degrees.